My name is Gabriel Garcia and I want to become an electrical engineer.
My name is Nathan Duarte and I want to become an electrical engineer.
My name is Joe Mesa and I want to become an aerospace engineer.
My name is Danny and I'm a biomedical engineer.
My name is James Baldwin and I'm a mechanical engineer.
My name is Julio Navarrete, electrical engineer.
My name is Lou Tai and I'm computer science. And my name is also Helica Gutierrez and I'm biomedical engineer. Chicago.
And we are the Dream Team.
My name is Victoria Serrano and I am a PhD student in electrical engineering.
My name is Elizabeth Basani and I'm a graduate student in electrical engineering.
And we are Team Super 7.
Our hypothesis was the best vehicle would travel 10 centimeters per second. We did distance divided by time to get velocity, and we calculated velocity to get average velocity, and it was 3.36 meters per second.
We calculated the angle using SOHCAHTOA, which is opposite over adjacent, which equals 61.8 degrees. The equations that we used were maximum distance, which equals velocity times the cosine of the angle times, which equals 0.95 meters. And our maximum height was velocity times the sine of the angle times minus 1/2 times the gravitational constant times squared, which equals 0.8 meters. Now our drag was 1/2 times, we used drag to calculate drag by 1/2 times the density times the velocity squared times the coefficient drag times the area, which equals 0.0021 newtons. And our lift was 1/2 times the density times the velocity squared times coefficient lift times the area, which is 0.0013 newtons.
And here's the trajectory of our bluebird and our redbird. As you can see, bluebird went farther and higher. And here is a LabVIEW way to calculate velocity and angle. Here's a LabVIEW way to calculate max height and max distance. And here is our LabVIEW way to collect our noise data. And our noise data gave us the maximum noise of 0.5 volts.
If we ever do this outreach program again, we will most likely design the bird on SolidWorks for better wing material. And if anybody has any questions, you may ask.
I'm Bruno. I'm the aerospace engineer.
And I will be a computer science.
My name is McKenna and I'm going to be a computer science.
My name is Daniel. I'm going to be a mechanical engineer.
My name is Tyler McDaniel. I'm an ASU student in mechanical engineering.
I'm Dave Phelps. I'm also an ASU student in mechanical engineering.
I'm Michael Freyes, also an ASU student in computer science.
I'm a sound engineer looking to further my studies in computer systems.
We're Team T, and our bluebird was our better bird because it had a better velocity. But in my opinion, the redbird was better in real life situations because it had a constant results in its flight. And as you can see, for equations, lift is what helps the plane.
Right, you gotta have good balance. So what do you think about Big Dog?
Intimidating.
It's intimidating?
Scary.
Okay. This big dog is pretty old. Yeah, it's long. It's more than 6 years old. It says updated March 2010. This is older than 6 years. There's a lot more sophisticated, much more sophisticated robots than this. But I like showing it because people think it's weird.
today, we're just gonna be collecting data out of the bird that you built the first or the second week. And we just wanna see how much this is gonna be generating in noise when you make it, when you twist the rubber band like, I don't know, 20, 30, or 40 times. And then that data is gonna be recorded in the LabVIEW program, and then you're gonna upload it in Excel. Okay, so how do we do that? We're gonna start a new VI. We've done this before. You're gonna connect your board through the USB cable to your computer. Okay? And then you're gonna have, in the block diagram, you have to right click, and then you're gonna select measurement IO. In measurement IO, there is an option that says DAC MX data acquisition. Inside the data acquisition, we're gonna select DAC assistant. And once you select it, you just place it in the block diagram.
Garcia, I want to become an electrical engineer.
I'm Nathan Dwork, and I want to become an electrical engineer.
And then we have Angelica Gutierrez. She's studying to be a biomedical engineer. We have
Blue tie, computer science. I want to make sure I was.
I'm Danny Trent, and I'm biomedical engineering.
Jamie.
Jimmy Blogger, mechanical engineer.
Julio Navarrete, electrical engineer.
And then we're the dream team.
Yeah.
Okay, so.
Okay. So our hypothesis was by increasing thrust, it would increase our distance, and then by incorporating our.
My name is Gabriel Rodriguez Steele. I want to go to the Air Force for aerospace engineering. My name is Ismael Romero. I want to be a mechanical engineer.
My name is Alexon, and I want to become a mechanical engineer.
My name is Matthew Perez, and I want to become computer science.
I'm Kathy Jones. I am an aerospace engineering student.
I'm Mira Miniguez, and I'm a mechanical engineer.
I'm Elizabeth Pisani, and I'm an electrical engineer. I'm Victoria Serrano, and I want to become a PhD. Very, very soon. Being electrical engineering.
Alright, so here's how it is. This is our red board, and this is the data collected in a red board, which Izzy will explain. So, okay.
And I'm Drew Gutierrez, and I want to be an aerospace engineer.
My name is McKenna, and I want to be a computer scientist.
And that's our mascot.
Why is it Raphael? Because we get it done. Alright.
This is like the angle, like of the arm, and that's the opposite in vision.
And I want to be a mechanical engineer.
I'm Juliana Navarro, I want to be a mechanic.
I'm Mark Mendoza, and I want to be a civil engineer.
I'm Louis Stroll, I want to be a civil engineer, sustainability.
All right, I'm Matthew Hernandez, and I want to be an aerospace engineer.
Okay, I'm Jocelyn, and I'm currently a sophomore studying biomedical engineering.
I'm Alfredo, I'm a senior in aerospace engineering.
I'm Esther, and I'm a mechanical engineer.
For the question number 1, what was our lift? Our lift was 0.274 newtons. And for drag, our drag was 0.183 newtons.
And for the way we measured it is his arm length. It was
GSS Enterprise. This was made in the program that you guys are sitting in front of right now, using tools that I'm going to give you guys right now and a lot of time and patience. So if you guys are really interested in this, I'll teach you what you need to know today so that you can do stuff like this. And if you learn now how to do this, if you're really interested in being an engineer later on, then it'll really come in handy. What is this? Boba Fett. All right. All right. This is just a picture. I didn't download the file, but this is one of the MAVs that we're working on in our club. So that's a drone. We're going to put little engines, little motors in these parts, and we'll fly around. So.
I'm Alexandro. I want to become a mechanical engineer.
Electrical engineer.
And I want to become an electrical engineer.
Our hypothesis was by increasing thrust, it would increase our distance. By incorporating speed holes, it would decrease drag for the bluebird.
Want to become in the future?
I don't really know yet.
Not sure. You aerospace, and then mechanical. So you're working with 2 of them. Pick one. Ooh, yeah. Yay, yay. Okay, thank you. Thank you.
I'm Benji, and I want to be a mechanical engineer.
My name is Daniel, and I'm choosing between chemical engineer or mechanical engineer.
My name is Susanna, and I want to be a computer science.
Yeah.
My name is Joanne, I want to be a computer engineer.
Nice. I'm Bruno, I want to be an aerospace engineer.
So far we only have.
My team is the mechanical devils, and my hypothesis is if the bluebird had less glue, it would have glue better. Because the red bird, it didn't have as much glue as the blue one. And then we figured out that the red bird better.
velocity. So we got 886.862 centimeters squared. And we
And then we're gonna go to measurement IO, and then NI DAG, and then we go to the DAG assistant. Then we place it here. So it's gonna ask us if we wanna acquire signals or generate signals. So since we wanna acquire the signals through the microphone, we're gonna select here analog input voltage. And then we are gonna select our audio input left, which is what we have connected in here. Audio input.
And where does that connect to the microphone?
Yeah, the microphone is actually connected to the audio input. So we're gonna collect the audio input left and hit finish. And here we have to select all parameters such as the voltage input, and we know that for microphone signals it's gonna be between -2 and 2 volts, and here instead of having one sample on demand, we're gonna be collecting continuous sample, and we're gonna just leave this as it is and hit OK. And after we create that block, it's gonna ask us, there we go, it's asking us if we want to create this block in a loop. So we hit yes, and then in here we want to send this data to a graph. So in here we're gonna say here create and then graph indicator.
Oh, so that's why you're here. That's why you're here.
And then so there we go, we have the graph indicator.
Awesome.
And
I'm thinking of doing power electrons.
so we're gonna say that we wanna read it from -2 to 2.
Yeah, I'm trying to see if I can. I want to see if I can do.
Okay, and then we are ready to run the application. So we run it,
Something like.
and now we are just
I mean, my
gonna.
dream job would be in that, right? You have this one section that actually contacted.
Twist the rubber band.
But apparently it takes really
So
long to get it.
when we are gonna release it, you're gonna see that the signal increases in the graph indicator. So
And not necessarily with like the micros, because Intel would really know for
you see it's increasing the graph indicator.
new stuff for like internet things. You know what I'm saying? So like incorporating all the things. Yeah, and so I mean that sounds really interesting to me. You know?
That's pretty much it.
Like,
Unfortunately,
so they're trying to figure out, like,
you don't
so
see
if
that
there
the
are
graph
gonna be, like,
indicator,
software,
this,
kind of
the
software,
voltage signal increases that
what kind
much.
of processing power do
I mean, we can see the idea of it. Once we are getting it,
no, I guess for,
then we
I mean,
can,
that's the kind of stuff that I would love to do.
we can do
Yeah,
other
like,
analysis
I wanna get into it,
with that signal that we're collecting. Thank you.
How's the bird looking?